Hello, welcome to this video. In this video, we will learn properties of good refrigerant. So, a refrigerant typically should have a low boiling point. Now, what do we mean by low boiling point? Remember, uh, boiling point is nothing but the point at which refrigerant boils, which means, for example, there are refrigerant which can boil at minus 10 degrees Celsius, minus 20 degrees Celsius. So, it is like at atmospheric temperature they will be in the vapor state. But the low boiling point, for example, if we take a refrigerant which boils at minus 5 degrees Celsius, can give you cooling of minus 5 degrees Celsius. If you look at the vapor dome, you see, if you look at this vapor dome, we see if this is the temperature at which, if this is the temperature, let us say minus 5 degrees Celsius is the temperature at which this boils. So, this is the temperature which it gives cooling at, right. So, at atmospheric pressure, if this boils at minus 5 degrees Celsius, if we have liquid at minus 5 degrees Celsius, it can give you cooling. So, all it takes is low boiling point gives you a range at which it gives you cooling. For example, we have nitrogen whose boiling point is minus 196 degrees Celsius. So, it can be used to give you a cooling of minus 196 degrees Celsius, and at the same time it also becomes difficult for us to store liquid nitrogen. If at all you want to store at atmospheric pressure, you will have to cool it to minus 196 degrees Celsius. Otherwise, the other option is pressurize. Now, if we pressurize, we can even store it at room pressure, I mean room temperature. Okay. Now, high latent heat of vaporization. So, low boiling point is one property which is for a refrigerant to be considered as a good refrigerant. Now, high latent heat of vaporization. Now, imagine if this is the vapor dome, this length will tell us how much cooling we can get. So, longer this length, so this is what we call as latent heat of vaporization. Longer this length, higher will be the heat removed. So, higher latent heat of vaporization is desired from a good refrigerant. Now, higher critical point. So, we want to operate the refrigerant from liquid to vapor and vapor to liquid within this dome, right. So, within this dome. So, this critical point has to be high. So, it should not go to a state where there is no distinct difference between liquid and vapor state. So, outer this zone of vapor dome, we will not have a distinct difference between the saturated liquid and vapor state, it will be in the mixed states. So, that is not desired. So, higher critical temperature is what we want, and this has to be, this point has to be literally higher. Now, low specific volume. Now, what do you mean by specific volume? Specific volume is volume occupied per kg of refrigerant. Now, obviously, we want to have for the same mass, if the specific volume is lesser, so we can store it in lesser space. So, that is the idea, it should have lower specific volume. Now, what do we mean by low freezing point? For example, freezing point is the point at which the refrigerant itself gets frozen. For example, there are situations where we use water as liquid coolant, all right. So, we will have a refrigeration system, and we will have centralized condition system where cooling water is taken from here, I mean cold water is cooled here, this is the refrigeration system. Then that cold water is taken into a place where we want to use. Now, the limitation of this system will be, so instead of using this refrigeration directly in a place where it is needed, we will cool the water, and that cold water is circulated in a place where we want the cooling. So, in this case we cannot have cooling less than 0 degree Celsius, because water will be frozen at 0 degree Celsius. All you can operate is plus I mean plus 1 degree or 2 degree Celsius at least. So, that is because water itself get frozen at below 0 degree Celsius, we cannot operate it. So, similarly, low freezing point of refrigerant is desired because this it should not get frozen, all right. Now, moderate operating pressure, remember moderate operating pressure we are talking because we are having this vapor dome, we are liquefying it to by raising its pressure, and then we are expanding it or we are dropping the pressure in order to make it evaporated, right? Or we can say this is your condenser pressure, this is our evaporator pressure, all right. Now, this will be has to be close to atmospheric temperature, but this has to be based on its saturation temperature, right, based on saturation temperature. Now, in order to make it liquefy, what should be this range is important. So, in order to liquefy it, if at all you have to pressurize it so much, then your compressor becomes bulkier, compressor becomes heavier. So, moderate operating pressure means you will have to have a system where with very less increase in pressure it should get liquefied, then by dropping it, it should become vapor. So, this pressure range is what we are talking moderate operating pressures, all right. Now, we are also worried about the ozone depletion potential. There are synthetic refrigerants which are as of now they are being ruled out, but still they have got potential to deplete the ozone layer. So, its range from 0 to 1. I mean 0 means that does not have any depletion potential at all. 1 means which is the maximum. So, the range is given 0 to 1. So, lower is the best. If it is 0, like natural refrigerants like carbon dioxide, it has got 0 ozone depletion potential. So, ozone, it should not deplete the ozone. So, lower is better, 0 is much better, all right. Similarly, low global warming potential, it should not cause any global warming as well, all right. So, if there is a gas like a refrigerant which can contribute to the global warming like greenhouse gases, so we would like to reduce it. So, low global warming potential is one of the desired properties of a refrigerant, and it should have a high thermal conductivity. We know that the refrigerant is the one which carries the heat away, right. So, it should have a high thermal conductivity, and of course, it should have low viscosity. It should not be like toxic, so it should be non-toxic, should not be flammable also, and should not be non-explosive and non-corrosive. From operating point of view, there are many such uh, desired properties from the refrigerant. All right, we shall continue in the next class. Thank you.